Welcome to this demonstration of Cohesity's Enterprise API Automated Recovery for VMware Cloud Foundation with strict consistency validation. In this demonstration, I'm going to showcase the complete failure and quick recoverability of the entire management stack of the VMware Cloud Foundation, and during its recovery process, I will introduce a failure to one of the Cohesity nodes in order to validate the strict consistency model that is applied for high availability and data resiliency. So before I get started with the demonstration, let me describe what's going on in the environment here. So at the top of the screen, I have a clock, which will be utilized to measure the time that it takes to recover the infrastructure. Below it is a window which showcases or demonstrates a continuous ping to all of the different applications and components of the management stack within the infrastructure, as well as the 4 nodes that are part of the Cohesity cluster, which will then be utilized to perform the strict consistency validation check when I introduce a failure on one of my nodes during the actual recovery process. On the main screen here, you'll see that I have the SCDC manager, which is actually the brains of the VMware Cloud Foundation. In the same place, we'll have access to the Cohesity UI as well as the vCenter server, and I'll be able to traverse between them to showcase the different components that are available, how everything is running, but also at the same time, once I fail the components, what happens, the impact of those components, those systems not being available to the infrastructure, and how we're going to validate the full recovery of this entire management stack in some pretty incredible time from a recovery perspective. So I'll start by going through the UI and showing you, for example, the components of the management stack and how everything is working within the VMware Cloud Foundation deployment. Here I'm showing the workload domains, and actually here in particular, the one we're protecting, the management stack. There's a particular vCenter server, the clusters, the number of nodes that are part of that particular cluster. I'll jump onto the vCenter server and showcase how everything here is running in that one particular cluster, and it's also organized in a specific set of folders. You can actually see all the different appliances and virtual machines that are running there, all of them stored on virtual SAN, right? As you can see, a single data store there. And all the networks that have been defined in terms of port grouped, distributed port groups in this particular case, which are all configured and defined through NSX. So obviously vCenter is working, the SCDC manager is working. So now let me show you what the Cohesity interface looks like and what it takes to basically configure the protection of this infrastructure. We'll start by going to the policy manager. Within the policy manager, there are 2 specific policies that are defined to protect. One, the VMware Cloud Foundation core authentication stack. Here you can actually see the type of jobs that are prepared, the retention times. We also have another policy that is created in this case to protect the VCF core management components. Obviously, all the rest of the components that are the management stack. So the first one, when it comes to authentication, has to do with the PSCs and the vCenter servers. Here is every other component that's part of the stack. The SCDC manager, VROPs, Log Insight, everything that's part of the stack. It's actually, there's a policy protected there. Now I'd like to show you the information about the 4 Cohesity nodes that are part of this particular cluster. You can see 4 different IPs. And actually the reason for that is because we're going to introduce a failure during the process of recovery here. Here on the right, you can see that the 4 nodes are actually continuously being pinged and they're all accessible, which is the same reflection for every other component that I demonstrated and showed so far. The point here now is that we're going to look at what happens within the infrastructure once we try to introduce a potential failure and how do we bring it back. So what I've done here is basically I'm going to connect to a single ESX host where most of the virtual appliances for VCF are actually running, as you can see them here. Here's a screen where it contains the actual command that's going to make the API call to do this whole thing fully automated without touching it again. And that's just a simple syntax that actually be utilized to either programmatically put into one of your product solutions, some of the things you need to do so that you can actually launch this process automatically. But it could be very easily launched through the UI itself, as it takes only 2 particular steps to recover the infrastructure. At this point, what's happening in the background is that I've executed a PowerShell script, which is going to actually delete, not just turn off, but completely delete every single component, every VM that is within the management stack of this particular environment. So they're going to all be completely deleted. As you can see them there, they're fading away from the actual client. And the point is to actually simulate this failure. So what happens as the virtual machines is being deleted? You can see here on the right that typically when they're accessible, they're in green. We can see them when they start popping up in red is because they're no longer accessible. But it's not to the point that they're just simply being turned off. The virtual machines are being completely deleted from the virtual SAN data store, which is actually accessible to the VMware Cloud Foundation configuration. So once all of these VMs are fully deleted, the important thing to understand here is that the PSCs and vCenter server are part of those particular VMs that are being deleted, which poses a pretty interesting situation for a lot of the different data protection and recovery products that may be available today, where there may be a challenge to recover the infrastructure when the vCenter server is not around, and there may have to be a function where that has to be restored first before things can actually back in work in order. In this particular case, what's going to happen here is that the restore process is going to start the recovery onto an individual ESX host, which will be this one. We'll see it again after things are being deleted. To make things even more interesting, obviously the first thing that's going to be restored and recover very quickly are going to be the PSCs, both of them, and following the vCenter server in order to get the authentication stack back and running. After that's done, we'll be able to actually continue with the recovery procedure, which is fully automated. I won't be touching this ever again. So now that you can see here that everything's been successfully deleted, everything's actually blinking red, let me validate that the interfaces are no longer available. So for example, I want to traverse over to the SDDC manager and refresh the browser to validate and see that the actual portal, which I was accessing and I demonstrated before, is no longer accessible or available to the environment as of right now. So once I go into the browser tab here, once I refresh the screen, this takes a couple of seconds. You'll see that this is actually now gone, no longer accessible because the virtual machine, the appliance was gone itself. I'll try the same thing with vCenter. And obviously in this particular version of vCenter, we're going through the vSphere Flash client. So you can see how it's gone. Now I'm going to bring back the actual command prompt where I'm going to launch the recovery from. I'm going to look back at that one particular node where I'm going to, where the initial recovery of the authentication stack is going to start. So once I start the recovery process, I hit enter here, I will start the clock on the right-hand side. So now you'll be able to see the time that it takes to recover the authentication stack along with the rest of the infrastructure. And look, within seconds, exactly 10 seconds, the vCenter server appliance is already restored and is being powered on. Now there's a couple of things that are different here. This is something that is testing not just the recoverability of a virtual machine or an appliance, but also we're dealing with application availability. Obviously, vCenter server has to bring up all its services, but once all its services are running, specifically the one that allows us to connect to the portal, you'll see that the actual VM itself is going to be now pingable and it will turn green on this side. Now within almost just less than a minute, we have one of the PSCs online. Here's the other PSC coming back online, and the vCenter server are actually up and running. So you can see how quickly these virtual machines, these one portion of the management stack is actually up and running, and it's being actually recovered onto a node, onto a single host. So the dependency on the vCenter server to be able to recover the infrastructure is not something that impact us. And when from a Cohesity standpoint, we're able to do that directly to any node within the infrastructure. And yet again, this is fully automated through the use of our REST APIs. Now, while we're sitting here waiting for this sort of thing to start, what's happening is that I'm at this point waiting for the vCenter service to sort of get back. We want to make sure that the application itself and all its services are pingable and accessible, which can actually be identified here. You can see that the vCenter server, the PSC1 and the PSC2 are now coming back green, right? So as part of that process, now that's step one of the recovery procedure. Now the next one will be to bring back the rest of the components of the management stack. As you can see, they all remain sort of red, which means they're still all down, but we want to bring them all back up. Now, before we get into the process of bringing back the, as this process is in a continuously moving, we want to introduce, in particular, a failure of the secondary storage platform on the Cohesity cluster. In the interest of time, I'm going to speed up the process here a little bit so you can see that during the recording, so we don't have to wait as long as these things are actually processing. But you can see at the top of the screen on the clock the actual amount of time that it's taken to do the restore, and also as the virtual machines and the appliances are coming back and the infrastructure. And I want to do this so that we can get to the part where, as the restore is continuing, I want to get to the point where I now actually implement or introduce a failure on the Cohesity cluster while the restoring process is actually happening. Now, what am I trying to validate and test here is Cohesity's implementation for strict consistency, which basically means a consistency model which is utilized in distributed computing in order to provide resiliency and high availability to data and information in the event of potential failures. So what happens here is obviously we have the ability to distribute the writes that are coming into the infrastructure. So instead of having to eventually synchronize the data and update the new blocks that have changed, what happens here is that the way in which Cohesity has implemented this into the architecture is so that everything is added distributively in parallel so that we don't have any potential single point of failures. The point to validate here is that if you use eventual consistency and you test what I'm about to just do here right now, your recovery and any new data that's been created or added onto these applications or appliances that you've been using will basically be lost. All right. And the one point that I'm trying to validate here is that, look, here we have a recovery process. I'm going to manually basically turn off one of the actual Cohesity nodes, and in particular, the one that I utilized before to demonstrate the configuration and all the information that I showed here just briefly. So you'll be able to identify that once I turn off this particular node, I went in through the ILO settings. You can also look at the continuous ping process here, and you'll see that the Cohesity node, one of the 4 nodes, is going to obviously show up in red, and you can see it right here. That basically lets us know that we now introduce a failure in the secondary storage system, which would potentially cause a big problem if you didn't have the strict consistency applied as part of the way the solution works. So here, the restore is ongoing. Obviously, we're still going to now restoring the secondary components of the infrastructure. We can very quickly see that vCenter server is back and running. Within 14 minutes, vCenter, the PSCs, in the majority of these components are available. You can see how they're all listed there, and they're obviously listed in red because at this point in time, those virtual machines are not running or are not stored on the vSAN data store and are not in compliance with the actual SPVM policies. But as you can see how this is going to continue to run, the time passes, but you can see that obviously the number of appliances and virtual machines that are being restored onto the environment continues to grow as you can see them actually going here. I'll slow it down now, which is the point where actually we start getting things back online. And you'll be able to see that within about 20 minutes, you now have the vCenter server infrastructure up and running. The rest of the infrastructure is now actually been restored and it's available. And now this is basically the VMs themselves. Obviously, the fact that they'll still have to, the services will have to come back online, which is not something that is reliant or depending on the actual secondary storage platform for Cohesity. It's a matter of being able to get those applications up and running again. So there I show the actual interface and UI for the Cohesity appliance that failed. Not only am I showing the ability to have the strict consistency capability in place, you can see the failures here, but also this is also demonstrating Cohesity's distributed control plane, which now I introduced a failure in the node that I was utilizing, but then I went on to another node within the cluster, and I was able to get back the same information, identify the failures, and obviously the restore job, the process of the management stack is ongoing. So nothing stopped. You can actually see here that the number of red items within the list here are being reduced, and you can see how everything's coming back online. So now if I go back to check and validate that the SDDC manager was properly or successfully restored, again, being the brains of the VMware Cloud Foundation management stack in that infrastructure, it should be. And basically, I'm waiting for the refresh here to pass. And you can see that on the right-hand side, all of the actual components are back to being green. And within a couple of seconds here, we should see that this is actually back up and running again. Here it is. So now we have the SDDC Manager fully accessible. I'll try another refresh because it's missing some items there. There you go. So it's just a matter of being able to get the data back and be able to have access to the infrastructure in the environment immediately. Now I'll do the same obviously for vCNS Server. We saw it before that I was able to log in. And one of the things that's important to point out here is that we were able to demonstrate the full recovery of the management stack for VMware Cloud Foundation. And in all honesty, it happened under 35 minutes. So if you think about that, when was the last time you were able to recover from an infrastructure failure of this magnitude? You know, it could be 20, 30, 40 VMs within minutes. I know based on experience that even running DR exercises, you're not able to actually do this effectively in that amount of time. And the one thing to keep in mind here is that this is a recoverability play and not a availability play. We can achieve high availability through expensive implementations, a lot of solutions, replications with vSphere replication, SRM, Zerto, and all those different solutions that provide that level of availability from a replication standpoint. This solution implements recoverability to the point where even if your availability solution fails, you'll be able to reinstantiate from scratch the entire infrastructure within minutes. If I would have performed this same particular demonstration without the introduction of a node failure, this entire infrastructure would have been recovered in under 20 minutes. But still, at 40 minutes or so that you see here, it is an incredible amount of time to recover an entire infrastructure from a complete failure. I want to highlight and point out again, this is not replication. This was recoverability. The VMs were gone. They are not available. They were completely deleted, and we brought them all back within 40 minutes, while at the same time introducing a failure to the secondary platform, which actually speaks volumes. Obviously, I took the potentially worst case scenario to deliver this, and actually everything was successful. Here we're looking at everything back. All I need to do now is bring back the Cohesity node so that everything comes back into full compliance and everything's highly available. But from a test and validation perspective, nothing failed. The restore was successful and everything completed while even introducing a failure on the recovering infrastructure, which is happening on the Cohesity clusters. The capabilities of this solution introduces a tremendous value into the enterprise data center, and I hope everyone can actually appreciate it and understand the differences between availability and recoverability in this particular aspect here. The capabilities demonstrated with Cohesity here today can actually add a lot of value to your business continuity and BCDR plans. By adding availability with recoverability to your infrastructure will give you the best of both worlds. Thank you for watching.